Dear student, welcome to the lecture series of nanotechnology. Today, I'm going to discuss about one of the simplest physical vapor deposition technique known as close space sublimation technique for the deposition of the film. Dear student, please note that close space sublimation is a simplest technique and for the thin film deposition. In close space sublimation, we basically evaporate a precursor material. A precursor is a material of which we want to make or of which we want to be deposited as a thin film. So in closed space sublimation process, a precursor material is evaporated and then it is deposited onto the surface of substrate after the condensation. And after the condensation, the deposited precursor material is converted into a thin film. The beauty of closed space sublimation process is this process is low temperature process. Closed space sublimation may be done under the low vacuum pressure or it may be done at normal atmospheric pressures. So both the low vacuum pressure and higher or normal pressure have pros and cons. So I will discuss those in this lecture. So in a simple word, closed space sublimation is a simplest physical vapor deposition process through which we can deposit the thin film at a low temperature. Usually the closed space sublimation process deposit the material which have a melting point around 800 degrees centigrade or less. There are different types of setup. In some may be conventional and some may be advanced. In advanced closed sublimation systems, there are also heating setups for the substrate. Substrate are slightly heated above the room temperature from around 200 degrees centigrade, 300 degrees centigrade, or even 500 degrees centigrade. So this heat of the substrate may also increase the diffusion of the deposited film on the substrate. So there is a diversity of the machines designs for the closed space sublimation process. Before discussing the closed space sublimation process, dear student, what do you think? What the word sublimation mean? What is sublimation? Basically, dear student, sublimation is the endothermic process. Okay, sublimation is an endothermic process of transition of substance directly from the solid phase to a gaseous phase without passing through any intermediate liquid phase. So basically in closed space sublimation process, we directly transport or we do a directly transition of solid precursor material, which is usually in the form of a powder, into a gaseous phase material, and that gaseous phase material is transported onto the surface of substrate as a thin film. So sublimation is basically a process of transition of a solid phase of a material into a gaseous phase, which may be represented by a schematic diagram like this. So dear student, in sublimation process, initially the solid precursor is heated and it is converted into a gaseous phase. The conversion of solid phase into a gaseous phase is known as sublimation, whereas alternatively the conversion of a gaseous phase into a solid phase is known as deposition. So dear student, in closed space sublimation process, initially the solid phase of the material, which is usually in the form of powder, is heated and sublimated, mean that is, it is converted into a gaseous phase without any type of liquid phase between the solid and gaseous phase. So after the conversion of a solid precursor into a gaseous phase material, it is then again deposited onto the surface of the substrate, and at the end of the day the gaseous phase material is condensed onto the surface of the substrate and converted into a thin film. Okay, now if a solid material is converted into a liquid phase, solid is basically a state of matter. When it is converted into a liquid phase, this is known as melting. However, if the liquid material is converted into a solid phase, this is known as freezing. Freezing is applied for making ice in a refrigerator. In a case of if a liquid is vaporized and converted into a gaseous phase, this is known as vaporization. In a case if a gaseous phase is converted into a liquid, this process is known as condensation. Okay, so in a simple word, closed space sublimation process is based on closed space sublimation technique is based on sublimation process. In sublimation process, in closed space sublimation process, the solid is sublimated by converting it into a gas without passing through a liquid phase. Okay, and when the solid is converted into a gas form, the sublimation is done. Then the gaseous material is deposited onto the surface of the substrate, and it is condensed onto the surface of this substrate, forming a deposited thin films. So now let's discuss the closed space sublimation technique in a brief, thorough fashion. Student, closed space sublimation is one of the simplest type of physical vapor deposition process used to deposit a semiconductor which evaporate below 800 degrees centigrade. And that evaporated semiconductor material are coated onto the surface of the substrate like glass in both vacuum and atmospheric pressure. The target material have to be in the form of solid in either chunk or powder form. So basically, the precursor material which is used in closed space sublimation must be in the form of solid, chunk or powder form. Cadmium telluride, cadmium selenide and zinc oxide are most common material deposited at around 400 degrees centigrade to 600 degrees centigrade with a thickness around 1 to 10 micrometer within 10 minutes of deposition time, which is one of the fastest deposition time among the other type of physical vapor deposition techniques available. The base pressure used in closed space sublimation is around 10 raised to the power minus 4 to 10 raised to the power minus 6 torr. So now let's elaborate this statement in a brief fashion. Dear student, first of all, The closed space sublimation is a simplest simplest process available in physical vapor deposition process. What do you think? What is a physical vapor deposition process? Physical vapor deposition process is a process in which precursor material, a material from which we want to make a thin film. So in physical vapor deposition process, a precursor material is evaporated in a physical vapor deposition reaction chamber without doing any type of chemical reaction between the reaction chamber is transported onto the surface of the substrate, and then onto the surface of the substrate the evaporated precursor material is deposited and it is condensed and converted into a thin film. So dear student, closed space sublimation is a type of physical vapor deposition technique. This technique, closed space sublimation, is very diverse technique and it is used to deposit a semiconductor conducting material. The interesting fact to notice here is that closed space sublimation technique deposit the semiconductor material or material which have an evaporation temperature or which have a melting temperature less than 800 degrees centigrade. So this technique basically deposit a material with which have a low melting point. This technique is applicable for low melting point materials. Just please note that in closed space sublimation we can use wide range of substrates. Most commonly used substrate material on which usually the film is deposited are based on glass materials. They are glass. Okay, sometimes you can use silicon dioxide, etc., but most commonly glass material is used. The closed space sublimation is done both at very low vacuum and as well as atmospheric pressure. But in order, student, you have to keep this in mind. The film which is deposited at low vacuum is basically have a better quality and it will be better in performance and as well as in purity, whereas the thin film which is prepared by closed space sublimation process at atmospheric pressure or at higher pressure will contain lot of defects and impurities. Now what do you think? What is the reason why the film which is prepared at low vacuum pressure has less impurity as compared to the film which is prepared at high vacuum pressure? Just please note that when the reaction chamber is basically when the low vacuum is created in reaction chamber, the mean free path for the evaporated material from the precursor increases than the distance between the precursor material and substrate material. So when the mean free path between the precursor and the substrate material increases, this will result into lesser collision of the evaporated precursor material. So the precursor material will be easily deposited onto the surface of the substrate in closed space reaction chamber without any collision with each other and also without any collision with reaction chamber. So this will cause a highly pure thin film on the surface of substrate. In a case, if the closed space sublimation is done at high pressure or at atmospheric pressure, then this means that when the precursor material is evaporated in closed space reaction chamber, the mean free path of the precursor material in a gaseous phase become less than the distance between the precursor sample than the distance between the sample holder on which precursor is placed and the substrate. So when The mean free path between the precursor holder on which the precursor material is placed and the substrate is more than the mean free path of the evaporated gas molecule of precursor material. Then the gas molecule of precursor material will collide with each other. So due to this will result into an impurity and also defect in a deposited thin film because of the collision of the precursor gas molecules. So dear student, the closed space sublimation process or any vacuum based process for making or for depositing thin film is preferred to be done at low pressure as compared to atmospheric pressure or high pressure. Dear student, please note that the target material, or which is known as a source material, or it is also known as a precursor material in closed space sublimation, usually exists in a form of solid, and that solid will be in the form of chunk, or it will be in the form of powder. Usually just in industries, in a lab, like if researchers prefer to use the powder material, they evaporate the powder material in closed space sublimation systems. Most commonly material prepared by closed space sublimation are cadmium telluride, cadmium selenide, zinc oxide, zinc telluride, and zinc selenide. Okay, and these materials are basically deposited around 400 degrees centigrade to 600 degrees centigrade. So the processing of evaporation of these material is done at low temperature as compared to the other vacuum based techniques available. You can basically deposit thicker film around 1 to 10 micrometer by using closed space sublimation process, and the time of deposition in closed space sublimation process is around 10 minutes. This means that closed space sublimation process is relatively a faster process than the other physical vapor deposition techniques available. Please note that the pressure usually used in closed space sublimation process is around 10 to the power minus 4 to 10 to the power minus 6. So such low vapor pressure will give you a better quality in terms of deposition of the wide range of thin films. Students, please keep in mind that closed space sublimation system is a kind of homemade instrument. Like you can even develop the closed space sublimation system at home. So it is quite easy to develop the closed space sublimation system at home. Another interesting fact to notice here is that closed space sublimation is more common for the preparation or for the fabrication or for the deposition of photovoltaic thin films. So they are more commonly used for a deposition of the film with having a photovoltaic properties, and most commonly thin film prepared by closed space sublimation, as I have previously discussed, are zinc telluride, zinc oxide, cadmium telluride, cadmium selenide, and zinc selenide or zinc telluride, etc. Okay. So the student, the closed space sublimation technique resemble with other types of physical vapor deposition processes or physical vapor deposition technique. Now, what do you think? What make the closed space sublimation? How we can distinguish a closed space sublimation process from the available other physical vapor deposition process? Dear student, the key point to notice here is this, that the source and the substrate in closed space sublimation are brought very closer to each other, and the distance between the substrate and the source material is around 1 to 5 millimeter. So this is the first distinguished feature of closed space sublimation process, that in this process the precursor material which we want to deposit is brought close to the substrate on which we will deposit the thin films. The distance between the precursor material, source material or sample holder is and substrate on which we want to deposit thin film is around 1 to 5 millimeter. The deposition in closed space sublimation process may be done under vacuum or it may be done under room pressure. Usually the closed space sublimation is done in the presence of gas species like nitrogen, argon and hydrogen. The source and the substrate temperature are fixed and they are in the range of 200 degrees centigrade to 800 degrees centigrade, and they may vary depending on the condition and requirement. So the student, in closed space sublimation, the temperature of the substrate and as well as the source material is vary around 200 degrees centigrade to 800 degrees centigrade. So this means that we can do closed space sublimation even at very low temperature. The temperature of source material, which is basically evaporated in closed space sublimation process, may vary and depending on the melting point of the source material, it may vary around 800 degrees centigrade and even more. But the temperature of the substrate is slightly down. It may be in the range of 200 degrees centigrade to 500 degrees centigrade. Just please note that the higher temperature is required to evaporate the source material from the sample holder, whereas slightly higher temperature is required for substrate in order to have a better diffusion from the deposited thin film. If we slightly heat the substrate material from room temperature, the the material which is evaporated from the precursor material, when it will be deposited, the slightly higher temperature of the substrate will make the deposits in film very easy to diffuse inside the substrate. So in this way we basically get a good quality thin film with better adhesion. So basically the temperature is in closed space sublimation process is required for both substrate and as well as for the precursor material. In conventional closed space sublimation, usually the closed space sublimation is done at slightly higher temperature, but the substrate temperature is just kept at but the substrate is kept at a room temperature. Now, student, please note that the closed space sublimation process has a higher growth rate than other physical vapor deposition techniques. The growth rate of the closed space sublimation process is around 500 micrometers per minute. So this technique provides you a slightly higher growth rate, and they which make which if you want to produce thin film at large scale in a shorter time, you can use close space sublimation process for this. Okay. All elements with higher vapor pressure can be sublimated to a vapor phase, okay, including carbon, silicon, selenium, phosphorus, and some compound semiconductors such as zinc sulfide, zinc selenide, zinc telluride, cadmium sulfide, silicon carbide, and aluminum nitride, etc. So basically, student, please keep this in mind. This technique is very good. This technique is useful for those materials which have a slightly higher vapor pressure, because the lower vapor pressure materials have their own complexity I will discuss those, that what are the complexity associated with the lower vapor pressure deposition technique. So there are different um, other techniques were used for the deposition of the lower vapor pressure elements, but for higher vapor pressure element, closed space sublimation method or closed space sublimation technique is very effective. So you can basically deposit broad range of element, and you can prepare the thin films of broad range of material by using closed space sublimation. Some of the common technique elements which we can deposit are carbon, aluminium, arsenic, arsenite, antimony, selenite, selenium, phosphorus, etc. However, I personally prepare like zinc telluride, zinc selenite, cadmium telluride, cadmium selenite thin films by using this process. So this process, this technique is basically more is more applicable, is mostly used for the deposition of the photovoltaic thin films. Now, student, let's discuss the construction of closed space sublimation instrument. Like, what are the essential part present in closed space sublimation instrument? Let's construct it. Okay, student, closed space sublimation apparatus may be designed on the basis of required material to be coated on substrate. So basically, student, you can produce a homemade closed space sublimation apparatus, and it's depend on you. You can vary the design of the closed space sublimation apparatus on the basis of the material, on the basis of precursor material, and on the basis of substrate on which you want to deposit thin films. In case of cadmium telluride, the distance between the source material and substrate is usually kept at a close distance of 12 millimeter. So the student, please note that the melting point and also other physical parameters are also associated for the distance between the material, precursor material and substrate. Usually for the cadmium telluride, the distance between the precursor material, which is basically cadmium telluride, it may be in the form of powder or chunks, and the substrate is kept around 2 millimeter. However, this may vary. It depends on material to material. Even with cadmium telluride, you can vary. Especially this is for researcher. Okay, you can vary the distance between the cadmium telluride precursor and the substrate 3 millimeter or more, or even 1 millimeter. So you can check that what is the effect of keeping the distance away and keeping the distance closer to the substrate material, like what will be the change in the thickness, what you can achieve in terms of physical and as well as chemical properties. Okay, so you can do experiment by varying the distance between the substrate and as well as the precursor material. However, conventionally, average distance is kept around 2 millimeters, especially for preparation of the cadmium telluride thin films. Okay, so this basically, dear student, the distance between, in case of cadmium telluride, the distance between the source material and substrate material is kept around 2 millimeter, which can also be changed by some simple technique like increasing the spacer of certain thickness. Top and bottom heaters can be chosen according to the temperature needed to evaporate either in the atmospheric pressure or vacuum. Okay, so this student, you can, as it is discussed, that you can vary the distance of the precursor material which is and the source material by increasing the space between the between the precursor material and as well as the substrate material. And please note that the closed space sublimation system may use different types of heating arrangement. Usually, the common closed space sublimation systems have top and bottom heater, okay, and these heaters basically are used to evaporate a precursor material from the sample holder. The top and bottom heaters are arranged in a specific direction. They basically target the precursor material, okay. So in case if you want, let's say if you want to prepare material having a higher melting point, so basically in that case you can use top to bottom heater with a higher temperature. So you basically, the student, you can change the intensity, the temperature of the top to bottom. Uh, uh, you can basically change the heaters, top to bottom heaters, according to the desired requirement of the melting point of the substrate material. Okay, so the temperature is basically is, is usually it is used to evaporate the precursor material. Another interesting factor is that the closed space sublimation, the top to bottom heaters can be chosen according to the temperature needed to evaporate either in atmospheric pressure or vacuum filling with certain gas like argon and nitrogen. Okay, so basically heater in closed space sublimation process are used in both in low vapor pressure environment, and they may be used at local or at atmospheric pressure. So please keep this in mind. The low vapor pressure or low vacuum pressure basically this provides you a diversity in terms of the purity of the deposits in film. However, the atmospheric pressure has a drawback of causing defects or causing collisions of the evaporating molecule from the precursor material. So they may cause a defect in the thin films. And please keep in this mind that there are different types of gases like argon and nitrogen are also used inside the reaction chamber. So both the uh, gases which are used like argon and nitrogen, they have their own properties. They are used as a transportation gas inside the reaction chamber in a closed space sublimation system. Basically, they move the evaporated molecule which are evaporated from the precursor material onto the surface of the substrate. There is a need of good temperature controller which can be programmable in steps such as in increment in a time or hold a time. Okay, so the student, please note that the closed space sublimation system also require a temperature controller. What temperature controller do? Temperature controller basically increase a temperature of the reaction chamber with a passage of time. And when the temperature reach to the melting point of the material, the temperature controller, you can basically adjust the temperature controller at that point. So and after that material will be easily evaporated. So programmable controller is essential for closed space sublimation operators. Finally, natural cooling is followed to be to let the temperature fall back into a room temperature. So then controller is just switched off and the heaters are switched off. So naturally the temperature is then decreased and the temperature and the reaction chamber reach to its original atmospheric low temperature. So in a simple word, let's summarize this. Closed space sublimation operators consist of a reaction chamber, okay? And in this reaction chamber, inside the reaction chamber, there is a precursor holder or sample holder on which a source material or precursor material is placed, and the other part of the reaction chamber consists of a substrate. Substrate is a material on which a precursor is deposited. Okay, the distance between the substrate and the precursor holder in closed space sublimation apparatus is around 1 to 3 millimeter. This distance may vary depending on the melting point of the precursor material and also other requirements of the precursor and as well as substrate material. Okay, the closed space sublimation apparatus consist of top and bottom heater. The top and bottom heaters are adjusted in such a way that they give more heat to the precursor material to be evaporated. Okay, the top and bottom heaters are selected on the basis of melting point of the precursor material. Okay, closed space sublimation also consists of a temperature controller. Temperature controller is device which control the temperature. So initially in closed space sublimation process, the temperature is slightly risen and it is controlled step by controller. And when the temperature inside the reaction chamber reaches to the melting point of the precursor material, at that time the temperature is fixed. Now it's depend on you up to how much time you want to evaporate the precursor material. If you need a thicker film to be deposited onto the surface of the substrate, you can basically fix the temperature controller for longer time to evaporate the precursor material. Another interesting fact to notice here is that the closed space sublimation apparatus consists of gases like nitrogen and argons. These gases are basically used, they are act as transporter. They transport the evaporated precursor material from the precursor onto the surface of the substrate, which at the end of the day are converted into a thin film. So now dear student, let us construct the closed space sublimation apparatus by schematic diagram. Dear student, this schematic diagram will basically make you in a position to construct your own homemade or small lab scale closed space sublimation apparatus. Basically, dear student, closed space sublimation apparatus consist of a reaction chamber. So this is basically a schematic representation of a reaction chamber. The student, please note that the closed space sublimation apparatus use a reaction chamber which is usually made of fused silica or glass. Really, it is just kind of transparent silicon dioxide. Okay, so the reaction chamber of closed space sublimation apparatus consists of windows located at different positions. So from windows you can basically see what is going on, what is going inside the reaction chamber of closed space sublimation apparatus. Furthermore, dear student, closed space sublimation apparatus consist of a few doors like these or few input sites like this. So the precursor material and also a substrate may be incorporated through these inlets or inputs of the reaction chamber of closed space sublimation apparatus. Dear student, closed space sublimation apparatus consist of a source holder or sample or precursor holder. So this is a schematic representation of a precursor holder. Usually the precursor holders consist of pockets in which source material or precursor materials are incorporated. So dear student, let's explain the sample the precursor holder in technical terms. The closed space apparatus use sample holders or precursor holder having very high melting temperature. Do you know, dear student, why closed space sublimation apparatus use the sample holder or precursor holder having a high melting point? If the melting point of the sample holder is less than the melting point of the sample which is present inside the sample holder, then this will cause incorporation of impurities from the sample holder into a sample or into a precursor. So this is the main reason that the sample or precursor holder temperature, melting temperature, must be very high as compared to the source material. Secondly, the temperature of reaction chamber must be less than the melting point of the precursor holder. Okay, usually different types of refractory or transition metals are used as a sample holder in closed space sublimation apparatus. Apart from refractory metal, most commonly ceramics boards are very common and they are used as a sample holder. Ceramic boards which are used may be based on zirconium oxide or silicon oxide, etc. So wide range of range of ceramic holders are used as a precursor or a sample holder in closed space sublimation apparatus. So inside the precursor holder, the source material or precursor material is incorporated. Dear student, please note that closed space sublimation apparatus use the source or precursor material in form of solid powder or in the form of chunk of material which we want to evaporate. Okay, so this source material in closed space apparatus is evaporated, and the source material is a material which will be converted into a thin film by condensifying its vapor phase into a solid thin film. So dear student, the reaction chamber of closed space apparatus consists of substrate holder. So the substrate holder is a holder in which substrate is adjusted. Okay, it's like this. This is basically a schematic representation of substrate which is present inside the substrate holder. Okay. So now, dear student, please note that every vacuum based system in which you are going to deposit thin film on substrate requires specific pressure. If the pressure of reaction chamber is at atmospheric temperature or it is at higher temperature, then the source material which is evaporated from the source holder or precursor holder will have lesser mean free path, than the mean free path between the source material and the substrate in the substrate holder. So due to lesser mean free path of the evaporated source material, they will cause a collision with each other, and due to a collision of the source material inside the reaction chamber, these collision may be take place with the wall of the closed space sublimation apparatus and also by the case molecule with each other, and due to this they will result into a non-uniform deposition of the film onto the surface of this substrate. So dear student, low vacuum pressure is very important for vacuum based apparatuses. Different types of vacuum pumps are used to decrease the pressure inside the reaction chamber. These vacuum pumps include mechanical pump, a rotary pump, turbomolecular pump, and diffusion pump, and there are also many more. The pressure usually used inside the reaction chamber in closed space sublimation apparatus is in the range of 10 to the power minus 4 to 10 to the power minus 6 torr. So that pressure is usually achieved by using simple types of turbo or thermomolecular or mechanical or rotary pumps. However, in case if you want to prepare very sophisticated and very uniform thin films with very small ratio of impurities on it, you need to use the combination of different types of pumps. So the combination of different types of pump, when they are used, the pressure inside the reaction chamber may further be decreased from 10 to the power minus 6 torr to even up to 10 to the power minus 12 torr. So at that such low vacuum pressure, they will basically cause a very good quality film deposition onto the surface of the substrate. So dear student, please note that it's depend on you that how you design your closed space sublimation apparatus. The thin film is basically deposited onto the surface of the substrate. However, what do you think? How basically you deposit a thin film? For deposition of thin film, you need to heat this source material. So this source material is heated by incorporation of heater, and the heaters are in closed space sublimation apparatus are usually incorporated above and below the reaction chamber. Student, keep in mind you have to adjust the position of heaters in such a way that they interact maximally with source material. This heater used may be based on are usually based on thermionic emission, and they are mostly tungsten filament or high temperature bulbs. So it's depend on you that what kind of heaters you want to use. But interesting fact to notice here is that the heater must have higher temperature than the melting temperature of the source material. So you can adjust high temperature or low temperature heaters depending on your processing requirement. Okay, so when the heaters are incorporated inside the reaction chamber, the interesting factor here is that the closed space sublimation apparatus have a temperature controller in it. Temperature controller is very important device. Basically, temperature controller is connected like this with the heater. Basically, the temperature controller increase temperature step by step. Like let's say if we want to reach the temperature of the heaters up to 800 degrees centigrade, we can basically adjust the temperature controller, like you increase the temperature from room temperature to 10 degrees centigrade in 1 minute. So just in 1 minute the temperature will be increased up to 10 degrees centigrade above the room temperature, and after another minute the temperature will further increase up to 10 degrees centigrade in other minute, and similarly after some time the temperature of heater will reach to the desired temperature which we want to use in closed space sublimation apparatus. Now dear students, when you reach to the temperature of the source, melting temperature of the source material, you can fix at that time the temperature of the heater. Okay, so basically usually the the temperature of heater used in closed space sublimation is slightly more than the melting temperature of the source material. Okay, so the temperature controller will fix the temperature of the heaters slightly above the melting temperature of the source material. Okay, so when the temperature of the source of the heater reach the temperature of the uh, melting temperature of the source material, it will result into evaporation of source material. Another interesting fact to notice here is that in closed space sublimation apparatus we incorporate different types of gases like argon or nitrogen. These different types of gases like argon or nitrogen play a very important role in transportation of the evaporated source material onto the surface of the substrate. They are used, or they act as a transportation gases in closed space sublimation apparatus. So now dear student, please note that the interesting fact to notice here is that the distance between the source material and the substrate used in closed space sublimation apparatus is around 1 to 3 millimeters. So they are basically at very small distance from each other. This is not common in other physical vapor deposition techniques. However, the key feature of the closed space sublimation apparatus is the distance between the source material and the substrate material. So distance between source and substrate material is around 1 to 3 millimeter, but in most cases it is around 2 to 5 millimeter. Okay, so this is the distance between the so the 2 to 5 millimeter represent the distance between the source and the substrate. Okay, now dear student, when the temperature of the heater through a temperature controller reach up to the melting point of the source material, this will result into evaporation, or this will result into evaporation of the source material. Okay, so source material with the surface the source material at the surface will be converted into a gaseous molecule. Okay. So, and then the source material which is in the form of the gaseous molecule will be transported through a transportation gas onto the surface of this substrate, and as a result at the end of the day you will get a condensed solid form of thin film deposited with the help of closed sublimation system. So let's students discuss about the essential component of the closed space sublimation apparatus. That what are the essential component, what are the key component, what are the key instruments used inside the closed space sublimation apparatus. Just please note that closed space sublimation apparatus consist of fused silica glass tube chamber, basically the reaction chamber in which the deposition of the film is done in closed space sublimation apparatus is made of fused silica glass. So it is a fused silicon dioxide transparent glass. Okay, and inside the glass basically the reaction the deposition of the thin film take place. Then please note that the inlet and outlet of carrier gases are also present inside the closed space sublimation operation. Carrier gases are the gases basically like argon and nitrogen. These carrier gases are used to transport the evaporated gas molecule onto the surface of the substrate or onto the surface of the uh, onto the surface of the substrate. So the closed sublimation apparatus is also connected with inlet and outlet for the carrier gas. The closed space components have a source material holder. So now this is very interesting point. The precursor material may be used inside the source material, may be used in single sample holder. Like if you want to, let's say if you want to deposit zinc on a substrate, so you can use a single type of a sample or precursor holder in closed space sublimation apparatus. However, the closed space sublimation apparatus may have multi type of precursor holders. So in case if you want to prepare complex compounds, let's say you want to prepare zinc telluride or different types of compounds like aluminium, chromium oxides, or etc. So you need a different or multi pockets of sample holders in the closed space sublimation apparatus. So the multi-sample holder present in a closed space of sublimation apparatus make the closed space sublimation apparatus diverse. So due to this, basically dear student, you can prepare even a complex thin films. You can basically produce or deposit a complex thin films if the closed space sublimation apparatus have multi pockets or multi sample holders in it. So the student, the closed space sublimation apparatus also consists of thermocouple. You can basically fix a thermocouple anywhere inside the reaction chamber to monitor the temperature, to monitor the heat, that what is going on inside the reaction chamber, what is the temperature of source material and also the substrate holder. So basically you can use single thermocouple or even multi thermocouples. It's depend on you that how you can adjust the thermocouple inside the closed space sublimation apparatus. The student, closed space sublimation apparatus consist of a substrate holder. As I have previously discussed, substrate holder is a holder in which substrate is fixed. You can basically have a multi-substrate holder in closed space sublimation apparatus, and you can have a single substrate holder in a closed space sublimation apparatus. The reason of using multi-substrate holders in closed space sublimation apparatus is that you can deposit multi types of thin films. You can deposit wide range of thin films at same time. However, preferably a single substrate holder is most commonly used in closed space sublimation apparatus. Okay, dear student, I think I have not listed that you can also use a shutter before the substrate holder and also above the source material. So shutter is something which control the evaporation of the material and which control the transportation of the evaporated material onto the surface of the substrate. So basically with shutter, which usually it is electronically controlled, you can control the amount of source material transportation onto the surface of the substrate. Dear student, please note that closed space sublimation apparatus consist of heaters which are located at top and bottom. So Most commonly, the heaters used in closed space sublimation apparatus are based on IR lamp, but there may be different kind of heaters which are based on tungsten filaments. So it's depend on you that what is the requirement of the source material, up to what temperature you can melt the source material. According to that, you can adjust the temperature of the top to bottom apparatus, top to top and bottom heaters. However, most commonly IR lamps are most common in closed space sublimation apparatus as a heater. Please note that the closed space sublimation apparatus is connected with vacuum pump. You can deposit thin film at atmospheric pressure. However, the low vacuum pressure is preferred for any vacuum deposition processes because the low vacuum pressure gives you an opportunity to deposit a uniform film on the surface of the substrate. The pressure usually used in reaction chamber of the closed space sublimation apparatus is in the range of 10 raised to power minus 4 to 10 raised to power minus 6 torr. Another interesting fact which I have discussed previously is temperature controller. Electronically temperature controlling is very important. Basically, this device increases the temperature of reaction chamber step by step in a certain amount of time, and when the maximum temperature at which the source material can easily melt, at that temperature the temperature is fixed by electronically controlled controller, and at that point deposition start. And when deposition is completed, the temperature of the reaction chamber is brought down to the room temperature slowly by switching off the heaters and also the temperature controllers. Now, this is very important. The closed space sublimation apparatus, apart from shutter, which are used to control the thickness of the deposited thin film, which is basically used to control the evaporation and deposition of the operated material onto the surface of substrate. You can also control the thickness of thin film onto the surface by using quartz crystal sensor or thickness monitor. Basically, quartz crystal sensor tells you that how much or what is the amount of film thickness deposited onto the surface of the substrate. Okay, so basically these are the essential component of closed space sublimation apparatus. If I summarize the essential component of closed space sublimation apparatus, closed space sublimation apparatus consist of a reaction chamber. Number 2, inside the reaction chamber there is a sample holder in which a precursor material is placed, which is also known as a target material, and the precursor material or target material is in line with a substrate holder in which substrate is placed. Okay, the vacuum pressure is incorporated by using different types of mechanical, turbo or rotary or diffusion pump inside the reaction chamber. Different types of gases like argon or nitrogen gases are used as moving gases for the evaporated source material or incorporated by inlet of the reaction chamber. Okay, the reaction chamber is also connected with the temperature controller, which control the temperature of inside the reaction chamber. The reaction chamber is also have a point at which there is a thermocouple which basically monitor how much is the temperature inside the on this sample holder and at the substrate. Apart from these, the closed space sublimation apparatus consist of a quartz crystal which basically monitor the thickness of deposited film on the substrate. So now, student, if you are interested to deposit high quality thin film, then what are the key factors you need to consider in order to deposit high quality thin film onto the surface of substrate by using closed space sublimation apparatus? The first key factor is the seed quality. You need to use high quality seed in order to get a uniform thin film. Dear student, please note that substrate which is used in the substrate holder and on which the thin film is deposited is known as seed. The substrate used for thin film deposition is usually single crystal and it acts as a seed. Seed basically is a prototype which basically on which is used in a way that the deposited thin film follow the direction and the orientation of the seed. So let's say if the substrate which you are using has an orientation of 100, then the deposited thin film will preferably be deposited along the 100 plane. So the deposited film will be nucleated and solidified along this specific direction, along the direction which is followed by the seed. So dear student, in a simple word, the quality of the seed and orientation of the seed is very important in order to get the desired thin film along the orientation on which you want to prepare. Another key factor to consider in order to get a quality thin film is the crucible design. Crucible is basically a source holder. Okay, it is also known as a target material holder or precursor holder. So the design of the crucible material is very important. The student, the design of the crucible must be adjusted in such a way that maximum amount of the source material may be easily evaporated, so you can get higher rate of the deposited thin film. Secondly, you have to consider the melting point of the source material. If the melting point of the source material is closer to the melting point of the crucible, then there is a possibility of impurities from the crucible inside the source material, which will lead to impure, non-uniform thin film on the substrate. Another key factor to consider in closed space sublimation process is the source material vapor pressure. So you need to consider the vapor pressure of the source material. Low vapor pressure source material basically cause difficulty in evaporation and deposition, and the control of those materials is difficult. However, the material with higher vapor pressure are easily evaporated and deposited. So, in most commonly, closed space sublimation operators use the material having a higher vapor pressure. Another key factor to consider in closed space sublimation process is the sublimation at the surface of the source. Now, this is very important. You have to sublimate the source material in a uniform fashion. If the rate of the sublimation vary at different point of the source material, this will basically result into a non-uniform deposition on the surface of substrate, because the rate vary, the evaporation rate of the source material is varied. So due to this the deposited film will have variable thin film with a variable thickness on its different position on the substrate. Apart from this, dear student, please note that the purity of the source material must be considered. If the source material is impure, then the sublimation that material will also cause an impurity on the substrate in a thin film. Okay. Another key factor need to be considered in closed space sublimation process is a temperature gradient. This is very important. Okay, the temperature gradient between the source, there must be a temperature gradient between the source and the substrate. Okay, usually the source material have a higher temperature than the substrate holder or than the substrate temperature. And however, if the substrate is at a room temperature and the source material is at high melting temperature, then the deposition of the source material or onto the surface of substrate will be lesser adhesive. However, dear student, please note that if you increase the substrate temperature slightly above the room temperature, then basically this will result into a better diffusion of high temperature source material. So due to this, you can basically get a very good adhesive thin film. Another key factor to be considered in closed space sublimation process of getting uniform thin film is the transportation of gas from the source to the substrate surface. Usually different types of gases like argon, nitrogen, etc. are used as a transporting gas of the evaporated source material onto the surface of the substrate. So you need to consider those, you need to operate those intelligently in order to get and transport the evaporated vapor phase of the source material easily onto the surface of substrate in a uniform fashion. Another key factor need to be considered in closed space sublimation process for getting uniform thin film is the sublimation at the surface of the substrate. So you have to consider that how the sublimated material, which is in the form of precursor material, which is in the form of gaseous phase, interact with the surface of substrate. Student, please note that the surface of the substrate, if let's say if you want to deposit a uniform thin film, so in order to get a uniform thin film, first you need to slightly increase the temperature of the surface of the substrate. So when the temperature of surface of substrate increase, this will cause a better diffusion of the sublimated gas of the precursor, and you will get a better thin film. Apart from this, you need to consider that the surface of the substrate must be clean. So due to this, there will be no impurities of the deposit in the deposited thin film. Okay, and you have need also to consider the roughness of the surface of the substrate. If there is a higher density of roughness on the surface of substrate, this will cause basically a non-uniform, even porous deposition of the thin films. So in order to get a better uniform thin film, you need to consider that surface of the surface of the substrate must be uniform and must be in less roughness. So now let us, dear student, make the closed space sublimation process explanation very easy by representing a closed space sublimation process with a flow chart. Dear student, as you know that the closed space sublimation system consists of a reaction chamber. Inside the reaction chamber there is a substrate holder in which a substrate is fixed as a substrate material, and the closed space sublimation reaction chamber also consists of a precursor holder or a sample holder, which is known as a target holder, in which a source material is present. So dear student, the reaction chamber is evacuated by using different types of mechanical, turbomolecular, rotary or diffusion pump. The pressure, the reaction chamber usually is taken down to a pressure, vacuum pressure around 10 raised to the power minus 6 to 10 raised to the power minus 4 to 10 raised to the power minus 6 torr. However, in case if you want to prepare very sophisticated uniform thin film, you can further decrease the vacuum pressure up to 10 raised to the power minus 12 torr by adjusting the combination of the vacuum pump. So dear student, the vacuum chamber is evacuated in the presence of source and as well as substrate material. After that, the source material is basically, dear student, it is heat treated, and similarly the temperature of the source material is taken up to a melting point of that source material, whereas the substrate material is slightly, the temperature of substrate material is slightly increased above the room temperature. So this will cause temperature gradient between the source and as well as substrate material, which will result into a better deposition, okay, which will cause basically diffusion, and at the end of the day we get better deposition. So after the evacuation and heat treatment inside the reaction chamber of closed space sublimation apparatus, the sublimation of source material, basically source material, starts above its melting point. So when the source material get sublimated, then before that the transportation gases like argon and nitrogen are introduced inside the reaction chamber. So these gases will basically transport the sublimated source material or the gaseous form of the source material onto the surface of substrate, which the sublimated source material will be converted into a solid phase. So basically this is an overview of the closed space sublimation deposition of thin film. Initially you basically have a reaction chamber. In reaction chamber of closed space sublimation apparatus, you have a substrate and as well as source material. The reaction chamber is basically evacuated around 10 to the minus 4 to 10 to the minus 6 star. After the evacuation, the source material and as well as substrate material are heated, and the temperature gradient is created between the source and the substrate material. The source material temperature is very high. It is above or closer to the melting point of the source material, whereas the substrate temperature is slightly above the room temperature. So due to high temperature gradient and high temperature of above the melting point of source material, the source material basically gets sublimated, or it is converted from the gaseous from the solid phase into a gaseous phase. And after sublimation, the gas molecules which are act as a transportation gas molecule like nitrogen and argon will transport the evacuated or will transport the sublimated source material onto the surface of the substrate, and at the end of the day they transported gas source material will be converted into a solid phase by condensation, and at the end of the day you will get thin film by close space sublimation process.